When performing Megger testing on 600-volt cables, particularly in roadway lighting installations, it's crucial to adhere to established standards to ensure accurate readings and avoid misinterpretations. A common point of contention arises when dealing with surge arrestors, which are often integrated into luminaires to protect against voltage spikes. These surge arrestors typically contain metal oxide varistors, or MOVs, which can introduce leakage during Megger testing, especially when multiple units are connected in parallel. The presence of these MOV can significantly lower the insulation resistance reading, leading to a false indication of a problem with the cable insulation itself. To address this issue and provide clarity, several standards and expert organizations offer valuable guidance. Firstly, IEEE 400.2, titled Guide for Field Testing of Electrical Power Apparatus, offers comprehensive recommendations for testing electrical equipment in the field. This standard specifically addresses the issue of surge arrestors and their impact on insulation resistance tests. Secondly, IEEE 494, titled Recommended Practice for the Design and Installation of Aerial Distribution Cable Systems up to 20 kV, provides guidelines for aerial cable systems, including considerations for surge protection and testing procedures. It is important to note that according to IEEE 400.2, Section 4.21.3, surge arrestors should be disconnected during insulation resistance tests. The rationale behind this recommendation is that surge arrestors can provide a low resistance path to ground, thus giving a false indication of low insulation resistance. This can lead to unnecessary troubleshooting and potential replacement of perfectly good cables. Similarly, IEEE 494 in Section 6.2.2.16 explicitly states that surge arrestors shall be disconnected during the Megger test. This reinforces the importance of isolating surge protection devices to obtain accurate insulation resistance measurements. In addition to these standards, several expert organizations can provide further assistance and clarification. One such organization is the Illuminating Engineering Society of North America, or IEEE, which is a recognized authority on lighting standards and practices. Their website, www.wise.org, offers a wealth of information, including technical publications, educational resources, and industry standards related to roadway lighting and electrical safety. Another valuable resource is the National Electrical Contractors Association, or NECA, which represents electrical contractors and provides guidance on best practices for electrical installations. Their website, www.necanet.org, offers access to industry standards, training programs, and technical resources relevant to electrical contractors involved in roadway lighting projects. The International Association of Electrical Inspectors, or IE, is another organization that can provide expertise and support. Their website, www.ie.org, offers information on electrical codes, inspections, and safety practices, and can help resolve disputes related to electrical installations. When faced with conflicting opinions or interpretations of standards, it is often helpful to seek clarification from multiple sources. Firstly, it is recommended to contact the manufacturer of the luminaires to confirm that surge arrestors should be disconnected during Megger testing. Manufacturers can provide specific guidance based on the design and characteristics of their products. Secondly, provide documented evidence of the applicable standards, specifically IEEE 400.2 and IEEE 494, to the engineer who is requesting the tests with surge arrestors connected. Presenting the relevant sections of these standards can help to support your position and encourage a consensus-based decision. Thirdly, request a site visit from a qualified electrical inspector to resolve the issue. A neutral third party with expertise in electrical codes and standards can provide an objective assessment and help to mediate any disagreements. It is also beneficial to consult additional resources that provide practical guidance on Megger testing and surge arrestor testing. These resources can offer valuable insights into the proper procedures and potential pitfalls of these tests. For example, online articles and technical publications can provide detailed explanations of the principles behind insulation resistance testing and the impact of surge arrestors and the results. In summary, when performing Megger testing on cables with surge arrestors, it is essential to disconnect the surge arrestors to obtain accurate insulation resistance measurements. This practice is supported by industry standards, expert organizations, and the manufacturers of the luminaires. By following these guidelines, you can ensure the reliability and safety of your roadway lighting installations. To further elaborate on the process of Megger testing and the considerations for surge arrestors, it's helpful to understand the underlying principles and potential sources of error. Megger testing, also known as insulation resistance testing, is a method used to assess the condition of electrical insulation. It involves applying a high DC voltage to the conductor of a cable or other electrical equipment and measuring the resulting current flow. The insulation resistance is then calculated based on the applied voltage and the measured current. A high insulation resistance indicates that the insulation is in good condition and provides adequate protection against electrical leakage. A low insulation resistance suggests that the insulation is compromised and may pose a risk of electrical shock or equipment failure. Several factors can influence the accuracy of Megger testing, including temperature, humidity, and the presence of contaminants. It's important to perform tests under consistent conditions and to clean the equipment being tested to minimize the impact of these factors. Surge arrestors, as previously mentioned, can significantly affect the results of Megger testing due to their inherent characteristics. These devices are designed to protect electrical equipment from voltage surges by diverting excess current to ground. They typically contain metal oxide varistors, or MOVs, which exhibit a nonlinear resistance characteristic. At normal operating voltages, a MOV have a high resistance, effectively isolating the protected equipment. However, when a voltage surge occurs, the resistance of the MOV drops dramatically, allowing the surge current to flow to ground. During Megger testing, the DC voltage applied to the cable can cause a small amount of current to flow through the MOV, even at voltages below the surge protection threshold. This current flow is known as leakage current and can vary depending on the type and number of MOV connected in parallel. When multiple surge arrestors are connected in parallel, the leakage current from each device adds up, resulting in a lower overall insulation resistance reading. This can lead to a false indication of insulation failure, even if the cable insulation is in good condition. To mitigate the impact of surge arrestors on Megger testing, it's essential to disconnect them before performing the test. This ensures that the insulation resistance measurement reflects the true condition of the cable insulation without being influenced by the leakage current from the surge protection devices. In addition to disconnecting surge arrestors, it's also important to follow proper testing procedures to obtain accurate and reliable results. Firstly, ensure that the equipment being tested is de-energized and isolated from the power source. Secondly, clean the equipment to remove any dirt, moisture, or contaminants that could affect the insulation resistance reading. Thirdly, select the appropriate test voltage based on the voltage rating of the equipment being tested. Fourthly, connect the Megger test leads to the equipment and apply the test voltage for a specified duration. Finally, record the insulation resistance reading and compare it to the manufacturer's specifications or industry standards to determine the condition of the insulation. If the insulation resistance reading is below the acceptable threshold, further investigation may be necessary to identify the cause of the low reading. This may involve visual inspection of the cable insulation, testing of individual cable segments, or consultation with a qualified electrical engineer. In conclusion, Megger testing is a valuable tool for assessing the condition of electrical insulation, but it's important to follow proper procedures and consider the potential impact of surge arrestors and the results. By disconnecting surge arrestors during Megger testing, you can ensure accurate insulation resistance measurements and avoid misinterpretations that could lead to unnecessary troubleshooting or equipment replacement. Consulting with industry experts, referring to relevant standards, and following manufacturers' recommendations can further enhance the reliability and safety of your electrical installations. Furthermore, it's crucial to maintain a comprehensive understanding of electrical safety practices and regulations. Working with electricity can be hazardous, and it's essential to take precautions to protect yourself and others from electrical shock and other potential hazards. Always wear appropriate personal protective equipment, such as gloves, eye protection, and arc-rated clothing when working with electrical equipment. Follow lockout/tagout procedures to ensure that the equipment is de-energized before performing any maintenance or repairs. And never work on energized equipment unless you are properly trained and authorized to do so. Staying informed about the latest electrical codes and standards is also essential for ensuring compliance and promoting safety. Electrical codes are constantly evolving to reflect new technologies, industry best practices, and lessons learned from past incidents. By staying up to date on these codes, you can ensure that your electrical installations meet the highest standards of safety and performance. In addition to adhering to established standards and regulations, it's also important to cultivate a culture of safety in your workplace. Encourage employees to report potential hazards, participate in safety training programs, and follow safe work practices at all times. By creating a safe and supportive work environment, you can minimize the risk of accidents and injuries and promote a culture of excellence in your organization. Moreover, it's beneficial to continuously improve your knowledge and skills in the field of electrical engineering. Attend industry conferences, participate in professional development courses, and read technical publications to stay abreast of the latest advancements and best practices. By investing in your own professional growth, you can enhance your expertise and contribute to the advancement of the electrical engineering profession. In addition to the technical aspects of Megger testing and surge arrestor testing, it's also important to consider the economic implications of these practices. Improper testing procedures can lead to unnecessary equipment replacements, increased downtime, and higher maintenance costs. By following best practices and ensuring accurate test results, you can minimize these costs and optimize the performance of your electrical systems. Furthermore, investing in high-quality testing equipment and training can provide long-term cost savings. Accurate and reliable testing equipment can reduce the risk of false positives and false negatives, while well-trained personnel can perform tests efficiently and effectively. In conclusion, Megger testing and surge arrestor testing are essential components of a comprehensive electrical maintenance program. By understanding the principles behind these tests, following proper procedures, and consulting with industry experts, you can ensure the reliability, safety, and economic efficiency of your electrical installations. Moreover, by fostering a culture of safety, investing in professional development, and staying informed about the latest advancements in the field, you can contribute to the advancement of the electrical engineering profession and promote a safer and more sustainable future. The considerations for surge arrestors during Megger testing extend beyond just disconnecting them. There are scenarios where understanding their presence and potential impact is valuable for comprehensive diagnostics. However, these scenarios require careful planning and execution, often involving specialized equipment and expertise. One such scenario is performing a ramp test on the installation with the surge arrestors connected. This involves gradually increasing the applied voltage during the Megger test and monitoring the current flow. The resulting voltage current curve can provide insights into the condition of both the insulation and the surge arrestors. A sudden increase in current at a specific voltage level might indicate a breakdown in the insulation or degradation of the surge arrestor. Interpreting these curves requires experience and knowledge of the specific equipment being tested. Another advanced technique involves using a guard terminal on the Megger. This terminal allows you to isolate specific sections of the circuit during the test, effectively bypassing the surge arrestors and measuring the insulation resistance of the cable alone. However, proper use of the guard terminal is crucial to avoid inaccurate readings or damage to the equipment. It's also important to remember that surge arrestors themselves have a limited lifespan and can degrade over time due to repeated exposure to voltage surges. Regular testing of surge arrestors is recommended to ensure they are functioning properly and providing adequate protection. There are specialized testers available for this purpose, which can measure the clamping voltage, leakage current, and other key parameters of the surge arrestor. Furthermore, documenting the results of all Megger tests and surge arrestor tests is essential for tracking the performance of your electrical systems over time. This data can be used to identify trends, predict potential failures, and optimize maintenance schedules. Creating a comprehensive database of test results and maintenance records can provide valuable insights into the overall health of your electrical infrastructure. In addition to the technical aspects of Megger testing, it's also important to consider the environmental impact of these practices. Megger testing typically involves the use of batteries, which can contain hazardous materials. It's important to dispose of used batteries properly to prevent environmental contamination. Recycling programs are available in many areas for the safe disposal of batteries and other electronic waste. Furthermore, consider using energy-efficient Megger testers and other equipment to minimize your carbon footprint. Choosing equipment that meets energy efficiency standards can reduce your energy consumption and lower your environmental impact. In conclusion, Megger testing and surge arrestor testing are complex and multifaceted processes that require a thorough understanding of electrical principles, industry standards, and best practices. By staying informed, following proper procedures, and considering the technical, economic, and environmental aspects of these practices, you can ensure the reliability, safety, and sustainability of your electrical installations. Additionally, remember that consulting with experienced professionals and continuously improving your knowledge and skills are essential for maintaining a high level of expertise in this field.